So I'll go ahead and start. I'll welcome everybody. Still have some people that are joining us and getting situated. And Francis gave me a financial report that we have $8,170 in our account right now. And we want to thank the people that have donated for the birdathon for the last year or made similar donations. Still not too late to do that. We'll post our people that have donated for the birdathon in the November newsletter. And if you wish to have your name listed as anonymous with your donation, you can do that. But amount that we're in good shape right now for our general meeting expenses. So the more we have in our account, the more we're going to be able to do in January when we start deciding what grants we're going to issue and how much. So we sure appreciate your support. And if you haven't donated, we'd welcome a check. Our birdathon or our bird feed account right now is in the hole by $175. We can put some of our money from our general account into that, but we mostly rely on donations from you. So if you would like to give some extra money for the bird feed account, specify that, send it in, and we start feeding, putting feed out at our 3 locations in November. Memberships are for our local chapter, $15, start January, and they go from January through December. The National Audubon, they go by month that you joined. So I found out myself that I'm no longer a member as of a couple days ago, and I will be writing a check, and I just happened to ask when it's due, because we don't see a due when your memberships are due on your national magazine. And some people like me don't get a reminder from National Audubon. So if you're not getting a renewal reminder, you might check with Francis, find out, or just send in a $20 annual national membership dues. Last year, we had a unique opportunity to participate as a group with the Waterloo Cedar Falls Symphony and the Jane concert. And unfortunately, because of COVID, that was postponed or canceled for this year and will be done in May next year. We requested to have all the ticket money that people had sent in for that, for our block tickets, to be refunded, and which we will do. We haven't, we had to do that through the UNI box office, and that's been closed until recently. So the request has been made, and a check will be issued to Prairie Rapids, and we will refund the amount to each and every one of you for the tickets that you purchased. When we receive that money, we'll send it out to you by the mail. So there was a survey that Candace put out for her favorite birds for this time of year. If you've seen that, you can check that. She'll put a tally together later. And I know some of the sparrows are starting to show up now. I'm getting some of those in my yard. We have had some late reports of warblers, such as a parula, black-throated green. A friend of mine had a summer tanager at his feeder, or his water feature actually, in his backyard today that he took pictures of. So if you have an unusual sighting or something you'd like to share, you can hit the chat box down below, and just as the program is going at any time, if you have a question or something to share, put it in the chat box, and Candace will look at that later. So for right now, I'm going to turn this over to Candace. We'll go over a little bit about the protocol with how we do things here on the Zoom meeting. And we have a special little video that's going to be shown, I hope. So Candace, take it away.
First, you unmute yourself And so those of you are probably familiar with Zooming. You should have a control bar at the very bottom of your screen, so you can unmute yourself if you'd like to speak. If you, for some reason, don't want your picture to show, you can mute your video, so it would just display your name. And any rate, like Tom said, if you wanted to submit a question or tell us what you've been seeing lately, Charles says that he's had a Carolina wren and white-crowned sparrows. Those are terrific birds. So yeah, just put them in the chat, just to hit that chat box if you've got something to contribute or a question. Also there's on the toolbar fun little reactions. So it's a little emoji, so you can applause or you can smile if you'd like to do that. So we're still learning, so please bear with us as we, navigate this online virtual meeting and whatnot. So, but there was a short video that we wanted tonight or not, but he could tell this tale. But this great horned owl was caught in a soccer net in Denver, Iowa. And that happens a lot to owls during soccer season. So, and this bird was rescued, and Kip Ladegi has shared this great picture. This bird was rescued and rehabilitated, Black Hawk Wildlife Rehabilitation Project, and has taken care of this bird, and they just recently released it. So here is a video of that release. And off it goes. So again, we want to thank the good people at Black Hawk Wildlife Rehab, Therese Evans, who took care of this bird in particular. They do great work. So if you ever find an injured bird or animal that needs attention, give them a call. Their phone number is posted on our website, gopraz.org. And they also are always looking for donations to help with the care of animals. They are also looking for volunteers that can help like transport. I've helped transport a red-tailed hawk before to Therese, and I got to release a painted turtle that had gotten rehabbed. And again, just the feeling of making a difference in these beautiful animals' lives is really satisfying. So, so we appreciate Kip Ladegi documenting this process with his photos and with that video. And again, thanks to all who were involved. Okay, I'm going to stop my sharing. And so that is.
Thank you, Candace.
You're welcome.
And thank you, Craig. I know you were involved, and I think you said there was like 32 people there at that event today. And Denver I was in the community of Denver where this owl ended up in the soccer net. It was kind of a group effort to get that rescued. And Denver is a bird-friendly community now, and so the the good things about birds is spreading through the community pretty well. They're doing some wonderful things over there. But I would have to ask Craig too, what was the highest count for? You did a number of swift counts, chimney swift counts. You had some people there earlier in September.
Yeah.
Do you remember how many chimney swifts were seen
Please go ahead.
total?
I think, can you hear me? I think
Yeah.
I think it's around maybe 230.
It's pretty darn good.
236, possibly.
It's a good
Hey, Tom.
community event.
Tom?
Yeah.
I might interrupt and just add that owl demonstration we just had, actually what happened was the coach was having a volleyball practice when they discovered it, soccer practice. And so it was those kids and that coach that actually called attention to this whole process, where they contacted Kip Ladegi, and then Kip came down and the rest of it, the story is told. But that man with the purple coat that released the owl was actually the person who discovered it in the net.
Well, thanks for sharing that. Thanks for the things that you guys do over in Denver. So
We had a pretty good turnout of about 5 nights of various people coming to the chimney swift sightings. Every night we'd go down for a few minutes and then four or five of the nights.
there you go. All right. Well, thank you. We'll get moving. I think we've quite a few people on. I'm going to introduce our speaker, who waiting in the background here somewhere, Anna. And Anna Buckhardt Thomas is our new avian biologist for the DNR, replacing Bruce Erzman. So she started in July of 2019, and she has been busy. And I know she's been busy with the derecho right now with things there, and then on top of all of her other duties. She has extensive experience in bird research, has a degree from Michigan Tech, an Upper Peninsula of Michigan, in wildlife ecology and management and applied ecology and environmental science. And she received her master's degree in wildlife ecology from the University of Maine, where she studied the response of the American woodcock and the golden winged warbler to habitat management. We're really excited to have her. We were going to have her last April, and because of the COVID, it didn't work out. So we're happy she could squeeze us in for October for her presentation, which is tracking bird migration for conservation. And it's something you've noticed if you read bird magazines and stuff, how much we've been learning about birds from new methods of tracking birds across the world. So there's a lot of information coming in, and we'll look forward to Anna's program. Before we start, you may, and I'm going to do this myself, is stop my video so we're not looking at myself and other people. And you may do the same too. Stop your video during the program so we're just watching Anna, and remain muted until the end. So Anna, take it away.
Thanks, Tom. Can everybody hear me all right?
Yes.
Yes.
Okay, excellent. And my screen is shared now, right?
Yes.
Okay, thank you very much. I'm so glad that we could make this happen virtually. As Tom said, I was excited to come out in April, and we were going to go birding, and it was going to be great. But I'm really glad that we have this opportunity tonight to get together. So thank you all for tuning in from home. And let's take it away. First, I'm going to just introduce kind of my background with birds. So I grew up in Northern Illinois. I was the daughter of an environmental educator who was a birder, and you can thank her for brainwashing me into this career path. I wouldn't change it for a thing, but thanks to Mom, I've been a birder for as long as I can remember. As Tom mentioned, I went to school in the Upper Peninsula of Michigan, and that's where I decided that wildlife and nature wasn't just a passion, it was going to be my career. During those summers is when I really started building my research and fieldwork experience. So I worked a summer in Hawaii, I worked 2 summers in California, I worked a fall in Nevada, doing all sorts of different bird work, largely with endangered and threatened species and the endemic species on the Big Island of Hawaii. From there, I decided that research was really exciting. And so I knew I had to get a master's degree so I could do my own research. And that's when I moved to Maine for about 3 years. A semester in, I went to Michigan to visit my then boyfriend at his banding station. So, you know, we're big nerds and we both like birds. And he proposed to me at a banding station. So if you weren't convinced yet that I was a bird nerd, there it is. We got engaged and took our engagement photos holding a golden crowned kinglet in Michigan. All of my master's work happened in northern Wisconsin, up near Rhinelander, working, as Tom mentioned, with American woodcock and golden-winged warblers and the young forest habitat birds. And shortly after that adventure was over, I moved here to Iowa. And so I've been here just over a year, and it's been really great to start to explore the state. And as an outsider, you think about all the corn, but you don't realize that there's a lot of really great habitat and really awesome places to spend time outside if you look for them. So I've really been enjoying my time here so far, and I'm learning every day. So tonight we're going to talk about migration and some of the science behind migration. So the first big question is, why do birds migrate? And it's really all about the resources. So evolutionarily, we know that many of birds that breed in North America are relatives and evolved from birds from South America. And so the resources, it kind of made this shift possible. So food is a major resource for breeding, obviously, and just for everyday survival. And because the Northern Hemisphere has this huge pulse in resources in the terms of arthropods and insects between April and September, there's this huge opportunity for birds to move in order to take advantage of that resource. And another resource that they're taking advantage of by migrating such long distances is nesting locations. So as the species continued to evolve and there continued to be more species in South America in the tropical habitats, there were less opportunities for nesting locations and competition. And so again, moving north gave them a higher, larger opportunities and more nesting habitat. And so these migrants, these neotropical migrants that move between Central and South America and the US and Canada every year have these pulses of resources that make it advantageous for them to fly so many thousands of miles. And so why do we research migration? Well, it really comes down to thinking about the full cycle of a bird throughout the year. So this is a golden-winged warbler, for example. Their breeding range is in dark pink, their migration range is in light pink, and their winter range is in blue. They spend about 4 months in North America during the breeding season. They spend 2 months migrating back and forth between their winter and breeding habitat, and they spend 6 months in their winter habitat. So as much as we think of the breeding birds of North America as our birds, they're really spending a very small amount of their year in North America on the breeding grounds. And so this is important when we think about their whole annual cycle and all of the factors that impact their life and their survival and their success. So there's these things called carryover effects, which are factors that happen in one part of the range that impact life in another part of the range. So for example, there's research that shows that American redstarts who have less food during winter or who have to deal with inclement weather during winter have changes in their migratory timing and changes in their fitness that affect their reproductive success the following year. And so all of this is connected, and if we're truly going to be able to conserve these species, we need to understand all of the aspects of their life and manage them in a holistic way. Other aspects of this are during migration itself, what sorts of resources are they using as they stop along the way? So how do we track migration as scientists? Well, the first obvious answer is observing birds. And I'll go through a list here and we'll talk a little bit about each of these throughout this presentation. We can also use bird banding, radio telemetry, something called pit tags, which we'll discuss later, archival data loggers, satellite tags, even weather radar, and something called the Motus wildlife tracking system. So we're going to talk a little bit about each of these interesting systems of tracking migration. So the first one is just observations of birds. And this is something that the average birder can help with through eBird, through Christmas bird counts and things like that. So this is the American goldfinch. All of these dense purple locations are high density of reported sightings. And this ends up giving you information about species range. So where on the globe does it exist during what periods of its life? It's a broad scale species-wide set of information. So you get information and associate with timing, you can learn about a species range throughout the year. So here you see the shifts in the American goldfinch. Here it is in its breeding range moving north, and then it goes back south for the winter a little bit. And so just through purely observations, we can find out information about birds, where they move during large periods of time. But you don't learn anything about individual birds. So we don't know where goldfinches from Iowa end up based on this system. But what we can learn additional information with is what we call bird banding. And so banding is a program that is administered through the US Geological Survey, which administers bands for all migratory bird species across all of North America. And these bands are usually made of aluminum, and they each have a totally unique number chain. And so these bands are basically like a bracelet that you put on, or like a medical bracelet that has your information on it. It's the same concept. It's around their leg, and then that individual will be uniquely identified. And then hopefully you set the bird free, and hopefully you catch it a few more times over its lifetime. And in addition to these bands where you can read the identification number only if you have the bird in your hand, there's also systems where you can put color bands on birds in unique combinations on their legs with multiple colors in different locations, and you can track an individual bird without needing to capture it again and read the band ID because it has a unique color combination. And this is really important for localized movements within one of their stationary periods of their life cycle. So you can identify individuals without having to recapture them. But as soon as they migrate, they're kind of lost until maybe they return next summer. Seems like it's going a little slow here. Let's see if it catches up. Oh, I don't know, it's thinking. Uh-oh. Okay, well, oh, here we go. Okay, it caught up again. So, can everybody hear me still?
Yes.
Excellent, thank you. Okay, so bird banding, it's great. However, the probability of capturing an individual that's been banded is pretty low. When there's so many thousands of birds of a single species and they're moving all over the place and you have so few banding locations, it's hard to know whether you're going to recapture a bird at all after you've banded it. And the other thing that this banding is helpful but also limited is that it gives you a snapshot of data. So you have information about the time it was captured, the location it was captured, maybe some morphometric measurements from when it was captured. And then you have hopefully at least one more capture in its lifetime, but you really only know two things about those 2 individual times in its life. You don't know how it got from point A to point B. You don't know who it's been breeding with. You just have these 2 little snapshots, which is, again, hugely informational and better than just observations, but it's still limiting. So stepping up from that, if we want to learn a little bit more about movements of birds, we can use radio telemetry. And so telemetry is a system that uses a transmitter, which is on the bird, and has a battery. It emits a signal, and then an antenna will collect that signal, and a receiver is used to translate that signal into something that, excuse me, that we can hear and detect. And so those radio waves are used to our advantage, and we can triangulate a location of a bird. Now, this is really helpful when looking at movements during a stationary period, so through a breeding season or with a resident species. But it can't track migration because it has a limited range. So these transmitters also have a limited battery life, which means that the transmitters will die after some time, and so they only collect data for so long. So a smaller tag means a shorter life and a weaker signal, so you have to be closer to the bird to actually detect it. So these tags can range from a few weeks to a few months of life, and they have a range about 1 kilometer. So if you're within 1 kilometer of the bird, you can detect their signal and get a triangulation for where the bird is. And so this is really helpful for these localized movements and understanding patterns of habitat use during a single season. So for example, this is a study done in Alabama with male cerulean warblers. They put transmitters on these male cerulean warblers, and then they went out repeatedly and got location fixes using their antenna, and they found they were able to create these gray polygons, which are the general habitat or the home range of the bird, and then these dark polygons are the locations that are most heavily used by the bird. And they also went out at night and found locations, and these white X's in each of these represent their roost locations or a site that they found while the bird was asleep at night. And so this is the sorts of information that we can get. It's really great on a localized scale, but as soon as this cerulean warbler decides to migrate, we've lost contact with it. Here's another example of really interesting radio telemetry work. This was done in Europe. This is a little owl, and the little owl has radio telemetry locations in blue. Each of these squares was a location where they did trapping for voles, which is the prey of the little owl. The white squares had no voles detected. The yellow squares had low vole densities, and the red squares had high vole densities. And you can see that the blue dots align with the heavy food and prey abundance. And so you can relate a location to a prey source, a food source, a particular habitat component, and learn some really important things about the lives of these birds. So moving on to another technology, this one is called a PIT tag, or a passive integrated transponder. And so for most birds, we attach these to their leg, like you see on this tit. And so it's just on a band on their leg. And so these transponders don't have batteries in them, which means they last a lifetime. The thing that has the battery is a short range antenna. But because it's short range, it can only detect the tag if the tag is within a meter of the antenna. So this is, again, limited, but really interesting for looking at things like a particular bird at a nest or at a bird feeder. So if you can find a bird on its nest and you can put a PIT tag on it, you can learn things about how often it feeds its young or how often it comes on and off the nest, and similar with feeding. So some really interesting stuff. And because there's no battery in the PIT tag itself, you can continue to gather information for a longer period as long as you can pinpoint a location where the antenna is likely to pick up the bird. So quickly, I'm going to share this video, and I'll try to read the captions as they come up. This is a study that looked at hummingbirds using pit tags. Hummingbirds were detected at feeders. And so it's loading here, but just as a little bit of background, the hummingbirds are so small that you can't put a band with a pit tag on their leg. But following appropriate ethical protocols, you can insert a really small pit tag into the skin on the back of their, on their back. And so we know that this doesn't impact the lifespan or their daily activities, but it allows researchers to get some really cool information. So this study was done out of the University of Toronto, and here's a video of a female ruby-throated hummingbird. So here the female is coming to feed. This little circle around the nectar port is the antenna. As she inserts her head, it detects the pit tag in the back, in her back. And the detection triggers a recording of her mass with an electronic balance that's connected to the perch she's sitting on. And you can obtain dozens of records a day, automatically detecting small changes in mass and energy balance over both short and long periods. So I find this study really, really fascinating. It's such a cool use of a pit tag in my mind. So here's some results from the birds that they've tagged during the study. So if you look at the x-axis, the horizontal axis, it's time of day. If you look at the y-axis, the vertical axis, you've got the average mass of the bird. So hummingbirds go into torpor at night, and they lose a lot of their energy that they've stored up during the day. When they come out in the morning to start feeding, they're at their they're not quite at their lightest, but they're not at their heaviest. And throughout the day, they continue to pack on the weight. Even within a single day, they fluctuate, you see 0.3 grams, so that they're prepared to torpor at night again, which is really fascinating. And because of this pit tag technology, they were able to capture individual masses throughout the day for these birds. They also looked at the birds as a group leading up to migration. So here's an example of 3 birds weighed, the masses taken. And on the x-axis, you have the days before migration. So 0 is the countdown, the day they leave for migration. On the y-axis, again, we have the mass of the bird. And you can see starting at 10 days leading up to migration, that they just start packing on the weight and they're 2 grams heavier by the time they leave, which is something we would have assumed and something we can tell if we catch birds throughout a time period, but knowing the same individual through time is really fascinating. So moving up from pit tags, we have archival data loggers. And so one example of that is a pinpoint tag. These tags have 10-meter accuracy, similar to a GPS on your phone. They can be used on birds as small as 20 grams. These devices weigh about 1 gram. They have, the smallest of these devices has power to collect 8 to 10 locations per year. You can collect more locations with a larger tag, of course, but these locations then are really accurate, but you only get 8 or 10 locations over a whole span of a year. But because of that, you can program the timing of those locations. So say I'm really interested in when this yellow-billed cuckoo, where it goes on migration. And so I know it's going to migrate sometime between late August and October. And so I'm going to have the device take 4 locations between that window. And then I'm going to have them take a location in January, so I know where it wintered. And then I'm going to take another 4 locations during spring migration. And so it's not a complete map of the whole year of the bird, but it gives you a lot more information about potentially the route it's taking and where a bird that I've captured in Iowa may be wintering. So the one big downside is that these tags are archival, which means they store the data internally on the device. So you have to recapture the bird to get any data back. So that's the challenge. You set it free for a year, you hope the bird comes back, and you hope you can catch it again. So another archival data logger is called a light level geolocator, and that's the technology that I use for my master's research. So this is a golden-winged warbler with a light level geolocator on its back. A geolocator has a very different level of accuracy. So geolocators are accurate for 150 to 200 kilometer accuracy, which is basically the accuracy of a state or a region of a state. And so the accuracy isn't great, but what this device can do is collect data every single day for a year. And so although you might not get the fine scale detail, you can get a better sense of the route it's taking and the region it's using during wintering and the timing of its movements. So, and the advantage of this is that these can be used on smaller birds, as small as 10 grams, which is about the size of a large male golden-winged warbler. So, as I said, they collect daily data for up to a year. And again, it's archival, so you have to capture the bird to get any of the data back. So it uses a light sensor, an internal clock. It's attached to the bird around its legs, kind of up on its hips, and sits on the lower back of the bird. It doesn't impede their wings at all. So this device collects an average value of daylight every 2 minutes for a year on a scale of 1 to 60 or 0 to 64. And you can use this information to understand how long the day is by understanding when sunset happens and when the dark versus light happens. And day and night length can be extrapolated to find latitude. And then you can use it again to understand the noon and the midnight times, the middle of the day period and the night period, and that can be extrapolated to understand longitude. There is a little bit of error around the equinox when day and night length are so similar. So the few weeks leading up to and after the equinox, using this data, it's hard to tell what hemisphere the bird is in. So those two time periods, unfortunately, kind of line up with migration, which means that you have a little bit fuzzy understanding of migration for this data. So some research that used these devices outside of my own looked at both golden-winged warblers and blue-winged warblers. So these species are highly related. One study found that genetically they're almost 99.9% the same. So although they are clearly very visually distinct, they're very genetically similar, and they readily hybridize and create viable offspring. And so here's the ranges of the golden-winged warbler in golden, overlapping in green, and the blue-winged warbler only in blue. And so they were trying to understand where these birds are going for winter and if it had a difference regionally. So this study captured a bunch of golden-winged and blue-winged warblers in different parts of their ranges and put geolocators on them. And here they've connected their location of capture is up here, and their wintering range is in the blue and in the green. And so they're trying to understand if there's connectivity, which means do birds from the same population region here always winter in the same location? So for example, birds that breed in the Great Lakes population for golden-winged warblers ended up wintering in Central America, and birds that came from the Appalachian population ended up breeding in South America. All of the blue-winged warblers across the range ended up in Central America. So it's some interesting consistencies, but also differences within a population. So my research was along the same lines. I was interested in looking at both of these species again, but in 4 new regions, and understanding where they're going for their winter and whether there's this strong or weak connectivity structure. So we went out in the field. We used playback and mist netting to capture male golden-winged warblers. Each of them got a unique band and color combination. They all got a geolocator. So based on the data that we captured, we had to wait a year, hope that the birds came back, hope that we could find them, hope that they were still wearing their geolocator, hope that we could catch them. So it took a lot of work, but we put out about 25 geolocators, and we got back about 30% of them. So we were really excited with that. So here is the data after all of the statistical magic is done. These are going to be heat maps, and so the hottest part of the map, the white spots, are the most likely location, but because of error, we're including the possible range of where these birds might have been. So I will just, so we have two birds here. One was captured in Vermont on the June 8th bird, and the June 1st bird was in northern Wisconsin. Both of these are golden wing warblers. So here they are in their breeding grounds, just hanging out, doing their thing. You can see there's a bit of error, and the little bubble bops around a little bit. Now they're preparing for migration. We've got one that goes down and over the Gulf, and we've got one that just shoots straight across the Atlantic. Now they're wintering. The bird from Vermont is in Colombia. The bird from Wisconsin is somewhere in Nicaragua, Honduras region. And so you can see again, there's some error. The location fluctuates a little bit. But pretty soon they'll start moving north again. So they'll start moving up to Central America, across the Gulf, and back to the Midwest, and again across the Gulf, into the Midwest, and then back over to Vermont and up to Wisconsin. So this is the sort of information that a geolocator can give you. It's at a broader scale, but it does give you the timing and the kind of exact path of how these birds are traveling between their wintering and nesting locations, which is really, really cool and super satisfying after a year of waiting to see such a really cool figure come out of it. So these birds ended up nesting in these different locations. So we had captures from Michigan, New York, Vermont, and Wisconsin. And you can see there, the little yellow or the little white circle is the centroid of where the locations were during their winter period. And that gray area is the 85% confidence region of where those birds wintered. Again, here we captured two blue-wing warblers, or a few blue-wing warblers, and here's the locations for those birds. So when we talk about connectivity structure between breeding and wintering locations, we've got the birds from Wisconsin and from New York that kind of have a similar pattern. The New York birds go to South America, the Wisconsin birds go to Central America. Looking at the Upper Peninsula of Michigan and Vermont, there's a bit of mixing, and birds ended up in both of those locations. And so the connectivity is not strong for these populations. Okay, so moving up to tags that require a little less intensive work and intensive calculation. So talking about satellite GPS tags. So these tags communicate with satellites to get GPS locations that are, again, within 10-meter accuracy. So these locations are basically like putting a point on a map in your Google, in your navigation system. And so this information is also communicated to the researchers through satellites or through cell phone towers. And so we don't have to recapture the bird to get the data back. So these transmitters are giving you almost real-time data, and you don't have to recapture them. And some of these units are solar panel charged, which means that they can last for several years. So you can get a lot of data, a lot of location information, and these are much more expensive up front, but you get a lot more data, and you don't have to do the process of recapturing the bird later. So these units are a lot heavier, so you can only put them on larger birds. So birds about greater than 115 grams. So a meadowlark is 100 grams, and they could take a GPS tag. It would just have a limit to the battery life and the number of locations it could get. But the general rule is you have to have 3% or less of the body mass of the bird is the tag size. So these, again, are high accuracy. They can tell you really fine levels of detail, like daily movements, and then fine scale migration routes and timing. So these will stay on a bird for long enough that we can see, this owl may nest up in the tundra, but it can show up in Minnesota in the winter, and we would get all of that information. So one study from my colleagues in Maine was with American woodcock. And so these birds, they were interested in migration, and so they decided to collect locations on the birds every 1 to 2 days during migration. And then every 3 to 6 days, those locations would transmit and be uploaded for the researchers to see. And this would last about a few month period. So it would get the migration cycle, but not a whole year of the bird's life. So they got information on this sort of scale where you get these stops and steps along the way. You don't know exactly how they got from the first point to the second point, but you know how long it took to get there and exactly where they were at that second point. So here's some example of the fine scale movement leading up to migration. And here's an example of a bird that stopped at a golf course for a few days to refuel along the way. And then they can get information about wintering location. They've also put out these satellite tags on birds during winter and watch them fly north as well. And so they get these really cool maps of the starting location and the end location and the stops along the way for a whole population here. Another study that's similar uses GPS tags. These GPS tags are also connected to cell phone towers, so they upload data through cell phone towers and get GPS data through satellites. So this is research that I've been a part of this summer here in Iowa. So we put these GPS collars, which are solar charged, out on trumpeter swans. Trumpeter swans are a big bird. They're the heaviest bird in North America, and so they're able to take a GPS collar that can last for 3 years. And so this is a collaboration with a bunch of other states in the region. It's headed by the University of Minnesota. And if you're interested in tracking and following our swans, you can go to this website, and there are the tracks that are uploaded daily of every single one of these birds, which is pretty fun to watch as they're starting to move now that the cygnets can fly. So here's an example of some local movements of a bird that we caught up at 12 Mile Lake in northwestern Iowa. So these birds are collecting data points every 15 minutes, every day for up to 3 years. And here's another example of their movements since August. So kind of a side study, in addition to those GPS collars, we're also putting collars on cygnets. And so we're interested in looking at survival of the cygnets over their first winter while they're hanging out with their parents. And so these collars do not have GPS on them. 40 cygnets have gotten these unique identifier collars. They're green. These birds will presumably be staying with their adults all winter, and as long as the adult GPS is working, we'll be able to track the whole family group. So if you come across any swans in Iowa this winter that have, or over the next few years, that have green collars or white collars, please go to our website and submit your observations. It will greatly help our research abilities. It's a really quick form to fill out just about the location and the identification of the bird you found. Okay, real quickly, I'm going to mention radar. So believe it or not, weather is not the only thing that's detected on radar. So rain shows up on radar, but so do insects and birds if they're in large enough quantities. And so in about the last 20 years, the research that we can do with radar has really come a long way. So quickly, I'm going to share this radar imagery. This is a video from, I think, 2009 during a peak spring migration movement. So you'll see that there's some rain in the system, but there's also a lot of migratory birds. And so at night, these radar will pick up those birds moving, and with lots of statistics, you can weed out the noise of what's an insect or what's a weather, and you can look at the birds. And so you'll notice as soon as sunset hits, you'll see a wave of migration come across the country. So all those birds are moving at night. So this is a lot of our passerines and sparrows and things. So those greens, some of them might be weather systems, but all those those blue highlights were birds picked up. So they can take this data then. Okay. Let's see. They can take this data then, and now they've created live what they call birdcast. And so these are maps. For example, this one was taken last night, just before midnight. You can see the directionality of the movement of birds and the density of birds moving in the airspace across North America. And so you see birds were leaving Iowa. Sadly, migration is on its end, but they're coming in hot down towards the Gulf Coast. A few hours later, at 5:30, you can see that push of migrants has moved even further south. So this is the sorts of live data you can use, and they've created models based on this where they can predict movements of birds a few days in advance based on weather patterns and previous migration maps. And so these forecasting systems are pretty neat. And if you're ever interested on, oh, I wonder if tomorrow's going to be a good migration day, these are a really good tool to be able to use to go birding with. Okay, and then finally, I'm going to talk briefly. I know we're getting close on time here. There's just so many fun things to talk about Motus wildlife tracking system.
Birds have the power to touch our hearts with their beauty and songs, to surprise and fascinate us with their behavior, to inspire us with amazing feats of strength and endurance. Some songbirds migrate thousands of kilometers every year in challenging conditions. Birds play critical roles in our ecosystems. They pollinate plants and spread seeds. They help control insects. Birds are also valuable indicators of change. Many populations have been seriously declining for decades. 1/3 of North American bird species need urgent conservation action to avoid extinction. We have to act now to protect the habitats and systems that support all life on Earth. But how? Scientists must unlock the mysteries of migratory birds and study their movements on breeding grounds, along migration routes, and in wintering areas. The Motus wildlife tracking system uses tiny tracking devices and a network of hundreds of receiving stations strategically located throughout the Western Hemisphere. Motus is yielding spectacular discoveries. Now, researchers can safely track bird movements over vast distances and with incredible detail to pinpoint the greatest threats to vulnerable species. The results help us identify conservation priorities and direct efforts and funds for maximum impact. Get involved today. You can help us conserve bird populations and habitats to ensure healthier environments for wildlife and for people. We have the power to make a big difference with your support.
Okay, so the Motus wildlife tracking system relies on the same technology as radio telemetry, but the advantage is that the tags are, the big advantage is that it's this international collaboration. So there's multiple antennae across the world, but they're all associated with the same system, and all the antenna and tags are on the same radio frequency, so they're all communicating and in the same general database and network. And so these tags have been used to track the movement of birds, bats, and things as small as insects, this is the smallest technology that you can put on the smallest critters to get this sort of information. So these tags are digitally encoded radio transmitters called nanotags, and they are constantly broadcasting a signal a few times a minute. And then these stationary antennae are always scanning for signals within about a 15-kilometer radius. And so the tag size determines the battery life, similar to the other tags we've talked about tonight. And so for a small bird, tags will last a few months or a migratory period. And for insects, tags last about a few weeks. So there's all of these towers out in the US. This map is a little outdated, but you can see there's a large number in the northeastern part of North America and along the Gulf Coast, but there's kind of a big gap in the middle of the country. And so that's kind of where Iowa fits in and how we can help potentially. And we do have a grant out to hopefully put up some towers in Iowa this next year. Hopefully that funding comes through, we'll see. So the other really neat thing is you can host a tower and detect birds without ever putting out tags. And so something like an Audubon chapter could host a tower and help researchers around the globe collect data that's really important to understanding migration. And so these towers are about $5,000 up front, and then some maintenance moving forward. But once it's in place, you can collect data on who knows how many species. It all depends on what flies within antenna distance of that tower. But since so many researchers are putting these tags out these days, I've heard people who have put up a tower and in the first 6 months gotten 3 different species and 6 detections of individuals. So there's really cool potential here. So this information can show you, for example, the migration routes of these different species. The Swainson thrush was captured right before spring migration in Colombia. You see it stopped in Panama, it ended up on the Gulf Coast, Midwest, and all the way up into Canada. You see where the red knot was captured and where it was later detected. And these tags are so small that you can use them on things as small as monarch butterflies. And so if you have a high density of towers, you can understand small migration movements like this butterfly that took a few weeks to travel between Lake Huron and Lake Erie. This research can also be tied to interesting aspects of a bird's physiology. So here's a study that looked at fuel loads or fat acquired at a stopover site and how it influenced the pace of gray-cheeked thrush migration. So these birds were captured pre-migration in Colombia and detected later in their migration. Here on the x-axis, you have the departure fat load, or the percent of fat above a lean body mass for the bird. And then you have the number of days it took before they were detected in North America. And so fatter birds go faster because they have more fuel, and lighter birds ended up traveling slower, likely because they had to stop more times to refuel along the way, which is something intuitive that we would have thought, but we couldn't have found this out on such a small bird without this sort of technology. Here's another quick study about rusty blackbirds. We learned a lot about their migration patterns. For instance, they're nocturnal migrants. Lots of people thought up until now that they were diurnal migrants. They also have long stopover kind of staging periods, similar to a shorebird, which will move to a location, stay for a few days to a few weeks, and then move again in a big jump. And they also have information about how their stopover duration is correlated with their body mass and condition and their molt status. So here on this graph, we've got molt score 2, meaning higher molt, and we've got stopover duration. So if you're in good condition, how molted you are doesn't necessarily affect your stopover duration much, but if you're in poor condition and high molt, you're going to stay for a lot longer at your stopover location. So all of these really cool technologies and all of this information that we can gather can really benefit our conservation decision making. So if we can understand migratory routes and stopovers, we can prioritize land conservation. If there are certain areas that are really important for certain species of migrant or are always along the pathway for all passerines, we can learn things about where might be priority areas to conserve. When we can use radar and other like GPS and tools to think about the timing of migration, we can inform strategies like lights out programs and windmill shutoff programs that reduce threats to birds during their migration periods. Thinking more about those GPS locations and how birds are using their habitats, what types of habitats are they using, what resources are they using, it can help us manage our public lands and even our private lands to make sure that we're benefiting species of conservation need. So really, we need to just think about understand the survival during migration as part of this whole annual cycle. So the threats during migration and their limiting factors during migration really may have a huge impact on their population growth. And so understanding how migration and migration connectivity and how their routes and timing affect their survival and their populations as a whole can really help us make informed conservation decisions to help protect the species. So I went over a ton of information there, but thank you all for sticking with me. And if we have time, I'd be happy to answer questions.
We do have time for questions, and some may have come on chat.
Oh, great.
Or if you do you have some, Candace?
I've got a question. So with regard to the populations of the golden wings that went to South America versus Central America, did you notice a different morbidity rate for birds depending on where they migrated to or from?
Sure, that's a really excellent question. So directly from my research, I didn't have a sample size that would really shed light on that question. However, that other study that I referenced, they had looked at understanding if their connectivity structures and where they're wintering is associated with population survival. And so we know for golden winged warblers that the Appalachian population is shrinking at a much faster rate than the Great Lakes population. And that Appalachian population is the one that's going to South America for wintering instead of Central America. So there's a likely connection between the wintering habitat loss and the wintering habitat scenario that those birds are wintering in, and that steep population decline, because we know that the breeding habitat in those regions is not limited because of extensive work that we've done to put breeding habitat on the ground, and it hasn't necessarily rebounded those populations. And so there's a strong connection between potential wintering location and the downward slope of that population.
Thank you. Anne had a question. What happens to the monitors after the birds die?
Sure. So it depends on the type of tag. If it's a GPS tag, a lot of them have a mortality signal. So if the bird stops moving, either it will signal and say, this bird is no longer, sometimes they can detect a heartbeat, for example. It'll say this bird doesn't have a heartbeat, and we can, because we have the location, we can go and retrieve the tag and potentially use it again on another bird. Or if it doesn't have the signal, we can still say, okay, that bird has been in the same location for 3 days, it's probably not alive anymore, and again, go and look for the individual. But on those tags where we don't have live data, so like for my geolocators, if you set the bird free and it doesn't ever come back, you never get the data back, you don't know exactly what happened. And so those smaller birds, you just lose the tags.
And I guess I misunderstood the question. So,
oh, sure.
But no, that was a great answer. But I guess Anne was wondering when the tags die. So when
sure.
They've expired. So
Sure.
You can answer both questions.
Sure, I'd be happy to. So for the most part, once a tag dies, we have no way to tell where the bird is anymore. So there's not a great way to go and capture the bird and take the tag off. So some of those backpack mounted tags, you can create the harnesses in a way that they will deteriorate over a certain amount of time and fall off with age. So for certain birds, you might have a tag that's too large for their migration, but you can make sure that there's a weak link in the harness that will deteriorate in 3 months and it will fall off before migration, or it'll be attached to feathers that will molt, for example. And so you can, to some extent, kind of determine when you want the tag to fall off for some of those. But for things like the trumpeter swan neck collars, those will be on the bird for the rest of its life, even if it's no longer working. But with our GPS collars, we also have a unique ID number on them. So even if people see them in the future, they can report them through that online site. And we'll still gather information about that bird throughout its lifespan, even if the tag isn't working anymore. And with birds that are that big, those tags, again, are such a small burden on their overall mass that it doesn't impact their life.
Great, thank you.
I have a question with what you would like to see Audubon chapters do to help you and the non-game division with your job or collecting research or whatever.
Well, that is an excellent question. So there are several things on my priority list that I would love to have volunteer and Audubon style groups help with. So one of those things is these Motus towers that I've talked about. Even if you can't necessarily fully fund a Motus tower, you know, if you could do fundraising and host a Motus tower, a $5,000 investment, and you can be collecting data for migratory research across the hemisphere, can be a huge research impact that you could have as a local chapter. And in terms of specific to Iowa, I intend to start a monitoring program for our nightjars and owls, which are one of our steepest declining groups of birds in the state. And so if volunteers can be dedicated to going out in a few times a spring and summer to go and do owl counts in different important locations around the state, that's the sort of thing that hopefully we can, once I've started developing these programs a bit more, I will definitely be reaching out to volunteers to hopefully help with that sort of thing. But vice versa, if there's things that you all see as a need, either research-wise or outreach-wise, that you think that I can help with, please let me know.
I have a question. How close together do those Motus towers need to be effective?
Sure, that's a great question. So ideally, you would have a sort of chain of towers that are within 20 kilometers of each other to make a sort of fence. And ideally, this would be a east-west fence of towers across a state or along an important geological feature, or it might be a north-south along a riverway, for example, along the Mississippi or the Missouri. And if they're close enough together, you're not going to miss any birds that might fly by. And so creating those fences makes it so that you can tell there, and if there are fences throughout the country, we can tell time steps of when birds move from Texas to Oklahoma to Iowa to Minnesota, you know? And so ideally, you would have high densities in lines across the country. However, we know that right now that's not necessarily practical. Some people have talked about ideas about, you know, putting them along interstates on telephone poles, or having wind companies collaborate and putting towers up on their windmills. So there's a lot of potential for putting them out. It's just getting the infrastructure in place and having someone who is in charge of all of it. So it's a large undertaking because it's a large geography. For Iowa, I've started with a grant to put up 7 towers. And so I have those towers spread northwest or east-west across the state, and I have them spread along the Mississippi River because I think that's the major flyway for us. And so that's a start, of course, but with local partners and county conservation boards, hopefully through time, we'll be able to fill in some of those gaps.
If somebody else has a question, you can unmute yourself and ask.
There was a huge bird die-off in the Southwest recently, Arizona, that area, thousands of birds they found dead on the ground. Have you heard any cause for that?
Yeah, so it's right now the consensus is that there was a mismatch in timing between food resources and a cold snap. And so this is climate change driven with the timing of and phenology of things. So usually in September when this happened, the birds are starting their migrations, but there's still plenty of insect prey. A lot of the birds that were found dead were swallows, swifts, warblers that rely on that insect prey. And so during that time period, Colorado got a bunch of snow. We had some swallow die off in Iowa as well that same week when we had the cold snap and rain. And so the consensus is that there was mass starvation because of this mismatch where the insect abundance was and availability had tanked for that week or so. There could have been some impacts as well from the fire smoke happening in the west, but the thought is most of those birds were just emaciated. And so the timing, they hadn't really started to pack on the pounds yet, but then it froze, and so they had to move, but they didn't have as much fuel as they usually do to move. And so that mismatch in food availability and migration timing was really that's the main thought of what really caused all of that.
Candace, we have some things in the chat room yet there.
John McCormick shared that he just uploaded some photos of the rusty blackbirds that he photographed at Diagonal Marsh last week. And I thought it was really interesting that the research had shown that they were nocturnal migrants. And again, those aren't birds that are readily seen in the States. So it's really cool that John found them. And so those of you who want to take a look at his pictures, click on photos at gopress.org. So when the rusty blackbirds migrate, do they both sexes migrate at the same time, Anna, or are they like the red-winged blackbirds where the males migrate at a separate time than the females?
You know, I don't know that offhand. I would assume that it's similar where there might be a little bit of a mismatch, especially in spring, where the rusty blackbird males would come back first and set up territories and the females would follow a week or so later. I'm not sure about fall, but that's a really good question and I will look it up.
I'm interested why you chose golden wing warblers for for your research.
Sure. So part of it was choice and part of it was that was the grant that had been written and the position that I got. But largely, so my research started off focusing on woodcock more than golden wing warblers. But golden wing warblers use similar habitats as woodcock. And so they're both in the early successional young forest habitats. And golden wing warblers are one of the species that are declining at the fastest rate of any North American passerine. And so in order to stabilize and reverse that decline, we need to know as much as we can about all aspects of their life. And like I said, that full annual cycle is a big piece of that. And so I wrote a grant and did some crowdfunding to get funding for those geolocators. And initially that aspect of things was kind of sort of a side project, but it ended up being like the bulk of my thesis and the most interesting and exciting part of my work to me. And so, yeah, so part of it was just fortune of being in that habitat, and part of it was previous work that my advisor had been doing. And so a lot of things just came together to culminate in a really cool species that I got to study.
Cool. And what a beautiful place in Wisconsin to do that too.
Definitely. I was very spoiled. I got to stay at a research station on a lake in Wisconsin in a hemlock forest, and it was just gorgeous. So I really enjoyed it. I can't say I love the black flies and the mosquitoes, but I got over it.
Yeah, right. Susan asks, where can we find links to some of the websites to be able to track the migration data, such as the Birdwatch?
For which program?
For Birdwatch.
Oh, the Birdcast with the radar?
Yeah.
Sure. So Birdcast is, if you Google Birdcast Cornell, they have a whole website and all of their up-to-date maps, all of their forecasting is all on that website. And that's the big one. But you know, anything at the Cornell Lab, all about birds, eBird, all of that has really great resources on a lot of information in migration. But Birdcast, I think it might even just be birdcast.org, or, you know, if you Google Birdcast Cornell, you'll definitely find it.
Great, thank you. I'll look it up, everybody, and post it on the website under our links page, okay?
Great.
Anna, I got one question for you. Is there any preliminary information coming through on the avian survivability after the derecho?
So I don't know. I don't have any data specifically about survival rates post-derecho. You know, unfortunately, with such like freak and quick happening event, you don't have time to plan a research study to understand what's going to happen because you don't know what's coming. So I know that there was a high volume of especially fledgling birds that came into rehab centers following the derecho. But in terms of a population level, at this point, we haven't seen any population level effects specifically from the derecho. Localized, I'm sure there are localized impacts. But luckily, a lot of those birds have the right adaptations and know how to survive big storms like that. So they stay close to tree trunks or low to the ground so that the wind isn't going to blow over their tree. They hang out in shrubs where it's lower wind speeds instead of on edges. You know, they have some adaptability to survive it. The main thing is if a storm lasts really long, they don't have enough food resources. They have such a high metabolism. In this case, the storm was about an hour long wherever you were, which is not enough time to have any impacts in that sense. But again, we don't have great data on population levels of direct impacts from the derecho. I would say locally, birds probably perished because of it, but on a population scale, I wouldn't think that it's gonna make a population scale impact in Iowa.
Well, Anna, we want to thank you for a wonderful, informative program. And this program will be on our website, archived for future viewing or for people that weren't able to join us tonight. Last month's program with Doug Haar is also on the website. And we've located a different way of doing that so we could focus mostly on the program, about the hour program that we've had. Next month, we have a program on grizzly bears. There was been interest in that when Vern Fish did some travel in Canada. There's Craig Myers he's a wonderful wildlife photographer, a friend and good friend of Jim Pease, who's agreed to do the program for us next month. And it's on Katmai in Alaska. So grizzly bears and probably some other things too from 6 trips that he's had up there to photograph grizzly bears and other things in Alaska. So we'll look forward to that. And we look forward to hearing about any of your sightings. And Anna, we'll look forward to having you maybe come join us when things calm down here a little bit.
Yes, I would love to.
Do some birding in the area, get to know us. We have some fantastic people here. And a wonderful Audubon group and others. So we look forward to having you again.
Excellent.
So boots on the ground. And if
Right.
there's ways we can help you other than you think of that we've talked about tonight, let us know. And
Excellent.
I would be happy to help out. So with that, unless anybody else has a comment or further question, we'll end the program. And thank you for joining. And it's treat time, I think, now. But we're going to have to not get in line for treats. So you have to feed yourself at home. So, well, thank you for everybody for joining us. We had a good crowd. And look forward to seeing you next month. Thank you, Anna.
Thank you. Very nice program. Thank
For
you.
those of you who are still online, if you read David Voigt's Popular in the Sky column that we have posted on our website and that I send out via email and it's in our newsletter, tonight is when Mars is in opposition to the Earth and it is going to be the brightest in the sky. right now. So something to go outside and look at. I certainly have been enjoying the celestial objects in our night sky, and looking forward to the blue moon on Halloween too. So anyway,
Thank you.
just to let you know too, the YouTube, the recordings are posted under the newsletter link on the website. And we've now got a YouTube channel where those will be stored. So, but you find the links to the recordings under the newsletter link on gopras.org. All right, thanks everybody. Appreciate it.
Thank
Take
you,
care.
Anna. We'll be sending a donation to non-game, if that's okay for,
Excellent. Thank you very much. It's
All
much
right.
appreciated.
you bet. Thank you.
Have a great night. Thanks for inviting me.
You bet. Thanks again.
For those who are wondering, Candace logged in under my name, so that's why Francis Moore's here twice. She was asking all the questions and keeping track of the chat